Hello, I am Shashikirtan Chigulla. Now we are seeing the project which is provided by EXPOSYS Data Labs. Here we need to develop a machine learning model which predicts the profit of 50 startup companies based on the given attributes. The given attributes to predict the profit of 50 startup companies are research and development, administration, marketing spend. So now in this project we are going to predict the profit of 50 startup companies based on these three attributes. First thing, before starting our project, we need to install these four libraries which plays major role in our project. They are pandas, matplotlib, seaborn, sklearn. Our project mainly consists of 5 steps. They are: initially we need to import the libraries, after that analyzing the data, after that visualization of data, after that model development, and then at last model evaluation. Let's go into the coding part. After installation, we need to import the four libraries. First thing is matplotlib, which shows the graphical representation and visualization of data. Second is pandas, which is for analyzing the data. Third is seaborn, which is for data visualization. After that, we need to import our 50 startup companies file into our project. Let's run. It is imported our file. Here we are seeing dataset.head function, which gives the first 5 rows of our CSV file. Let's run this. See, here we are seeing first 5 rows from the CSV file. After that we are seeing let's go to tail part. Let's run this. See, here we are seeing last 5 rows of the CSV file. These two, because by using these two we can confirm that our CSV file is imported successfully. Next, let's go to describe. Let's run this. It describe function. Just simply it describes the overall. See, by using the describe function, we can understand the overall schema of the project. That is count, mean, standard, minimum, 25%, 50%, 75% maximum. These all attributes are described here. After that, just simply here printing this print statement. This print statement is printing the number of rows and columns which are there in the CSV file. Let's run this. See here, it is showing that 50 rows and 4 columns are present in the dataset. So after this, we are using the duplicated function, that is any redundant values are there in our project or not. We are using this duplicated function to print this. So let's run this. Here we are seeing that 0 duplicated values in the dataset. After that, is null functions. Any null values are there in the CSV file, it will show. Let's run this. See, here seeing in 4 attributes 0 0 0 0, that is no null values. After this, info function. By using the info function, we can understand the overall scheme of the dataset. Let's run this. Here we are seeing 50 null values, non-null values, 50 non-null values. That is, there is no null values in our project. Next, correlation function. So CORR is nothing but it shows the correlation between the all 4 attributes. Let's run this. See, here we are seeing the correlation between 4 attributes. Next, we are using the heat map function. Heat map function is from seaborn. So from seaborn we are using the heat map function, which gives the matrix which displays the correlation in a visualized manner. Let's run this. See, here we are seeing the correlation. Just what we got here, that is only we are seeing here, but in a visualized in a neat manner with a help of heat map function. See here we are seeing the correlation. So next, outliers. So here by using the outliers, we can detect the outliers in our target variable, which is nothing but our profit variable. Any outliers are there, so we can able to detect that by using these outliers. Let's run this. Here we are seeing here is our target variable profit. See here we are seeing the outliers which are detected. Next, displot. This displot function is also from Seaborn, which gives us the histogram, which shows the average profit in a visualized manner in a clear way that we can understand. Let's run this. See, here we got the histogram, which is showing the average profit is around 1 lakh. By using this histogram, we can easily understand the average profit of the companies. Next, pair plot. This is also from Seaborn. Pair plot is used for understanding the relationship between the variables. So here let's run this. Variables in the sense, all attributes, we can understand the relationship between all attributes. Let's run this. Now see here we got the pair plots. So by seeing this, we can able to say that research and development is directly proportional to investment and marketing is directly proportional to profit, but there is no relationship between administration and profit. So these are the things we can able to understand with the help of pair plot. Next, we are using the ilog function. Ilog function, with the help of ilog function, so till here our analyzation part and visualization part is completed. Now we will start our model development part. So from here we will split the dataset into two variables, dependent and independent variables. So here we are using the ilog function, which selects specific rows and columns. Let's run this. Done successfully. Here next, we are importing the train test split function from sklearn model selection library. Here we are dividing the data into two types. They are training data and testing data with the ratio of 70:30. That's why here we are seeing the train size is 0.7. That is 70:30 ratio. We are dividing that. Let's run this. Done. See here we are seeing the training data which is provided to our model. Our model is trained based on these values. Next, we are importing linear regression function from sklearn linear model. This function we are using linear regression model in our project, which is the best, which gives where the results are best and pretty good accurate. So now we are using the linear regression model to train our data. This is simply our print statement. Model has been trained successfully. We are printing this statement because here with the help of this model.fit function, we are trained our model successfully. Let's print this. See, it is printing because we trained here. Just we are printing here. It is a print statement. So next, ypredict. By using the predict function, we can test the model using predict function. Using predict function, we can test the model. Let's run this. See, here are the predicted values. Let's check the testing score, model score of our project, where the training data, how much pretty good, how it is. Let's take the score of our model. Let's run 0.93. See, it is like pretty good. The score is accurate. Next, by using the pd.data frame from pandas, we can able to print the predictor value and actual value side by side. Let's run this. We can, after seeing the output, we will get a good idea. See now, the predictor values and actual values are displayed here with less error. Next, so here ends the development part. So now we'll begin the evaluation part. So model is evaluated based on these four things: R squared score, mean squared error, root mean squared error and mean absolute error. First, let's see that R squared. It measures the proportion of the variance in the profit values. That is, if the R2 score of a model is more, then the performance of the model is also more. That is, R2 score is directly proportional to performance of model. Let's run this. The score we got is 0.9341. If you want the score in a percentage, just we can print here R2 score into 100, then we'll get the percentage, that is 93%. The score, so it is, the performance is best. Next we are seeing the mean squared error. The mean squared error and RMSE indicate the average difference between predicted and actual profit values. That is, if the mean squared error and RMSE values are low, then the performance of a model is good. That is, it is inversely proportional to performance of a model. Then, so mean squared error and RMSE value should be less. Let's run this. See here we are getting 62. This is the MSE, mean squared error. Next, here we are printing the RMSE. Let's run this. Just simply it is a square root of mean squared error. RMSE is nothing but the square root of mean squared error. So at last we are printing the mean absolute error. So this is also indicates the average difference between predicted and actual profit values. So this value should be also low in order to better performance of our project. So let's run this. So here we got the values. So thank you. Here we completed our project. Thank you.